In all, over 100 people are now monitoring the final countdown operations.
Other people working are at the CVI, that's the Quick Look Telemetry Display Office, which sits atop the Montagne des Pères, which is behind us here in Jupiter. This is a spot where all the telemetry comes in.
Yeah, correct. The telemetry sent from...
Over to Claude Legrand and Remy Chevrier of the Quick Look Telemetry Center, whom we just saw, for a presentation of today's mission.
The launcher is composed of two parts. The first part is the Soyuz STB, composed of 3 stages. The second part is the nose module, composed of the frigate stage and the 2 satellites. 9 minutes after the liftoff, the Soyuz STB will inject the nose module into a suborbital orbit.
The flight of the Soyuz is tracked by Galileo station in French Guiana and by a station installed on a boat on the Atlantic Ocean.
After that, the frigate stage will manage a first boost of 13 minutes to inject the nose module into an intermediate orbit.
3 ground stations will follow this part of the flight. The boat station, Santa Maria on Azores Islands, and Osagel station near Toulouse. The end of the mission will be integrally tracked by New Nursia station near Perth in Australia.
During around 3 hours, a long ballistic phase will take place. After that, the frigate stage will manage a second boost of 4 minutes to inject the nose module into the separation orbit. At last, 3 hours and 48 minutes after the liftoff, the simultaneous separation of the 2 satellites will occur.
Remy and I will manage the real-time evaluation of the launcher data from the Soyuz Control Center. My colleague Antoine Courtois is in Moscow, where he will supervise the production of the orbital parameters.
Yeah, at minus 2 minutes 35, you will hear the DDO call out what the electrical umbilicals, those are the cables on the satellites, have been released. They drop into a metal basket designed for the purpose of retaining them.
2.5 minutes to go. About an hour ago, the gantry was moved back about 80 meters, revealing the launch vehicle that you see there. But there are many, many other launcher preparations that have already taken place.
Bagages ombilicaux Chao.
Ah, d'accord. Correct. At minus 4 hours 30, the tanks were filled with hydrogen peroxide. This took 20 minutes. Then at minus 3 hours 10, we filled the tanks with liquid oxygen. This took 45 minutes. And then at minus 2:55, they were filled with kerosene. These are all the different fuels that are used in the Soyuz vehicle.
Green status panels on the right continue to tell the story. All is go.
That's perfect. Once the launcher is filled, we have 3 days to launch. Otherwise, the fuel begins corroding the vehicle and it has to be emptied. But in this case, we are go.
We are fine for tonight. Just under 2 minutes, you will shortly see the people here in the hall moving out to the balconies on either side of Jupiter here. There's a fine view on the range, and people come here to take advantage of the fine weather and watch the launch. The DDO tonight, the voice you hear is Jean-Luc Voyer. That's the range operations manager from CNES. Thierry Villemart, whom we just saw, the Arianespace person who works with him. We want to say hello to everybody taking the broadcast tonight at ESA CNES Daumesnil in Paris in particular.
Yes, and also hello to everyone watching from
DDO. Attention pour A0 moins 1 minute.
DDO is going to call out the 1 minute mark.
Perfect.
Top. A0 moins 1 minute.
You want to say hi to your people?
Yeah, hello to the people watching in ESTEC and also to the operational teams in ISOC and the Fucino Control Center and the Oberhalbhofen Control Center.
All right, here's some things to watch for the ignition sequence. From minus 17 seconds to minus 6 seconds, the engines are tested automatically in 3 phases at about 20% of total thrust, then at an intermediate pressure about 50%. You see the arm falling away there. That's always a very exciting moment. And then finally at full throttle. At minus 3 seconds, the order is given for the full throttle. We'll let the DDO call out the final countdown, and we'll be back after Soyuz has cleared the tower. Enjoy the liftoff, everybody.
À 12, le DDO décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Décollage.
Well, we are underway. Soyuz lifted off from French Guiana. I guess we lost her to the cloud
La
cover
propulsion est nominale.
because the camera is not following her. The people are already coming in from outside on the terrace. But this is the 250th Arianespace mission to fly from French Guiana. And do you know what number Soyuz flight this is?
It's about 1860, no? 1,865.
61.
61.
61.
It's true.
So there's nothing like it. There's a shot. I picked up our camera
Yeah.
again of Soyuz burning. Tell me what went through your mind when you watched the liftoff.
Well, to be honest, happiness and
Le vol est
relief.
nominal.
Lots of people have worked very hard on this here and in Europe, and it's fantastic to see it flying. We need these satellites.
The boosters and the central core or second stage are burning now. The boosters weigh 45 tons each at liftoff.
Yeah.
The total mass is 178 tons of the first stage.
Yes, the engines run on liquid oxygen and kerosene, the same propellants which are used in each of the three lower stages.
And the second stage, similar to the boosters, its ignition occurred on the launch pad along with 20 engines at once
La
were lit
propulsion est
on the
nominale.
launch pad. As you saw, this stage burns for about 4 minutes.
Yep.
Now remember, Soyuz weighed 300 tons at liftoff. Now after separation of her boosters in about 2 seconds, can you guess what her weight will be? Just a guess.
It's about 135 tons. So this is very impressive. This means that it loses half her weight in about 2 minutes.
It's pretty amazing. There's the animation, the cartoon
Inspection
of
des
what it
moteurs
looks like
délégués.
up there. On the bottom
Préparation
of
des
your
propulseurs
screen, on the
moteurs.
bottom left, our altitude climbing towards 60 kilometers. On the right, our speed approaching 2 kilometers per second. Looking ahead, briefly, the mission is in 2 parts. After frigate separation, there will be, that's the 4th stage, there will be a first burn of its engine, which will last for 13 minutes. When this is over, frigate goes into what's called the ballistics phase, where it'll coast for about 3 hours, making its way toward where the satellites will be separated. And during this time, we'll cut away from the broadcast, but we're not there yet.
Yeah, we'll return in the air for the second frigate burn and satellite separation. It's interesting to see that Soyuz is built by RKT's Progress and the Samara Space Center, which also designs and develops the first 3 stages.
Soyuz, as we mentioned, goes back to the first days of the space race, introduced in 1966. It has everything going for it. It's a reliable vehicle, it's efficient, flexible, it's cost-effective, and has handled in one version or another, this is the second, it's an updated version for French Guiana, in all versions, all types of missions, from telecoms, Earth observation, to weather, science probes, Mars missions even, and it's the only manned vehicle able to reach the International Space Station. Isn't that right?
That's right, Josh. It's impressive. Some basic Soyuz facts. It orbited the first artificial satellite, Sputnik, in 1957, and also the first man in space, Yuri Gagarin, in 1961. Also the first woman in space, the first spacewalk, and also it has the highest demonstrated reliability record, close to 99%.
We've had jettisoning of the fairing, and you can see the 2 satellites exposed now to the elements. Those are the 2 black boxes. In the middle is the dispenser, which will push the 2 satellites away from each other when they are separated. The fairing measures how much? It's tall, right? It's
4.1 meters diameter and 11.4 meters high. I was next to it yesterday, and it's really, really tall.
You were dwarfed.
Yes,
by
completely.
the fairing.
Yeah, and we can now get rid of it because we are high enough in the atmosphere, so that there is not, actually the atmosphere is very thin, so there is no heating or friction, and then we don't need it to protect the satellites, and then by jettisoning it we have less weight and the launcher operates better.
So it's a good time to get rid of it now.
Yes.
We can also get rid of the second stage, which is coming up, the extinction of the second stage, coming up in about 3 seconds. You see the motor burning out and separation of the second stage, ignition of the third stage. Give you an idea of what that looks like up above. One particularity of the Soyuz is, whereas with Ariane, if you know Ariane 5,
Allumage du bloc I,
we separate the lower
extinction du bloc
stage
A, séparation du bloc
before
A.
igniting the upper stage. Soyuz does just the opposite. The third stage is ignited 2 seconds before separation of the second stage. It's curious. The lower part of the third stage, which is called
Lagage
the
de la section
skirt,
arrière du bloc I.
is used to channel the flux of this third stage motor ignition down towards the lower stage, where it rebounds, which I guess gives an added thrust, right?
Exactly. This means that the third stage can start firing before separation of the launcher's two elements. This occurs at 282 seconds after liftoff. Before this version of Soyuz, without the frigate upper stage, it was the third stage that put the satellite into the initial Earth orbit, but not in this version. And you have to see that during these 10 seconds, the Soyuz will climb 4 kilometers, up to 153 kilometers.
You see our altitude over 170 kilometers and our speed 4.3 kilometers. We've been picked up by our first downrange tracking station. It's a boat, actually, in the Atlantic. It's the Naval Transportable Station developed by the CNES. The DDO's voice continues to call out that all is okay on board. He's saying the speed is nominal, the trajectory is nominal, and he says, also confirms that we've been picked up by the first downrange tracking station.
That's perfect. Yep.
We're going to go to a launch replay in just a minute, the first of several launch replays, actually, so you can relive those very exciting moments of liftoff. If it's the first time you've seen a launch, it's always very exciting.
Indeed.
We have cameras at several of the, we set several of the observation sites along the base, and as they come in, we get their shots. Here comes the replay.
Bonne stabilisation du lanceur.
Lifting off rather rapidly.
Yes.
Much faster than Ariane 5, which is a much heavier vehicle, but not as fast as Vega, which goes up like an arrow.
I can imagine. Yes, I have never seen a Vega launch.
You should come down for that. I think you'd like that. The Galileo program began in 1999 when Europe decided to build its own satellite-based navigation system. Now I want to ask you, you're from ESA. What's ESA's role in the program?
Okay, Josh. There are basically three main bodies involved in Galileo. We have the European Commission, the European Union is the program manager funding it. And then we have the European Space Agency. And then we also have the European GNSS Agency. GNSS stands for
GNSS?
Global Navigation Satellite Systems. So it gets into a complicated acronym. We call it GSA for short.
GSA, okay.
Yes.
And what does GSA do?
So first we are the architect, ESA is the architect, we have designed and developed the system and we are in charge of making it work, and then GSA is in charge of implementing the services and maximizing the use of the Galileo signal.
So ESA overall, ESA's job is to oversee and fund the program?
No, the funding is done by the European Union.
Okay.
So we are in charge of designing and procuring the system. Right now we are in the finishing the deployment phase, which means that we are still finishing the deployment of the ground segment, and then at the end of the year we will start the exploitation phase. It's a different phase in which GSA, the European GNSS Agency, will have the role of exploiting the services, which will start this year in October with the initial services.
Soyuz continues to fly north, her path north, then east over Europe, where she's picked up by the Osagel station that is near Toulouse, that is coming up. Then she'll continue east over Russia, and then south, where she'll be picked up by Perth in Australia. This station there will see separation of the two Galileo satellites, just actually south of Australia. Coming up on third stage separation at 175 kilometers. We're right where we should be.
Yep.
And you'll hear the DDO call out that confirmation there. It looks like this third stage is separated on the animation there.
Extinction du bloc I, séparation du bloc I.
The DDO has just confirmed it. You may have noticed that events are announced by DDO with a slight delay.
Yes.
Of just a couple of seconds. This is quite normal. Why? Because information the telemetry and the radar, that comes into the ground stations that we've been talking about, then sent in here to Jupiter, have to be first confirmed. By whom? By our Russian teams. And where are they? Moscow.
In Moscow.
So they have to come here via Moscow. It takes just a few seconds.
Yes.
Then they come into the CVI, the Quick Look Center, which
Les
you saw
paramètres à bord sont
earlier.
normaux.
Everything normal on board, says the DDO. Can we talk about the ground segment now?
Yes, indeed. It's a very, very impressive ground segment. We have actually two, the control segment and the mission segment, and they are being used every day for the routine operations of the first satellites.
Right. You saw that the frigate has just been ignited. That's the first frigate burn, right on time. It'll go for 13 minutes.
That's very good. So, yes, the ground segment are being upgraded as we speak to increase their availability and operability. So we are implementing redundancies, so with the objective to have the two control centers with the deployment of the ground segments. In this case, for example, we will be able to switch over operations from one control center to the other with seamless upgrades in case of important failures.
And where are the control centers?
Confirmation du
They are
périmètre
one in Fucino, Italy, and the other in Oberpfaffenhofen, Germany.
Right. Okay. So they share the duties.
Yes, in this case, this is what our target.
All right. Frigate is burning. She will continue to burn for another 12 minutes or so. Then there will be a second burn in about 3.5 hours. That's a shorter burn, 4 minutes. We'll explain why that's 1/3 of the length of the first burn, but we'll explain that when we get to it. After the first burn, this first burn that's occurring now, the upper composite, we call the composite what's left of the 300 tons. The upper composite is spun up during what we call the ballistics phase. We'll explain that when we get there, and that lasts about 3 hours.
Yeah, correct. The frigate, then frigate will ignite her engine a second time for the 4-minute burn, which will circularize the orbit into the separation orbit for the satellites. Then the satellites will be released at 3 hours and 47 minutes after liftoff. These satellites weigh 730 kilograms each and will be separated together.
Now, why are they separated together?
It's more efficient this way. Then the frigate continues into its graveyard orbit, so that there will be a passivization later, and the satellites will start drifting into their target orbits.
Okay, we're going to a film on Galileo now, the first of a couple of them, presented by ESA, the European Space Agency.